Good evening and welcome back to Maths in an Empty Classroom with me, Mr. Sutton. This is part 2 of the lesson on sketching exponential graphs. There are 3 things that we need to consider when sketching exponential graphs, and indeed when sketching any graphs really, and those 3 things are the shape, the intercept or intercepts, and the asymptote. Now what I've done up at the top of the board here is I've drawn the 4 different ways that an e to the power of x sketch could take shape. The first is the standard e to the x graph that looks like this, like we saw in the previous part of this lesson. E to the negative x, now that would be a reflection of this graph in the y-axis, so the shape of that one's going to look like this. Negative e to the x is going to be a reflection of this one in the x-axis, so it's going to look like this. And then minus e to the negative x, 2 ways of thinking about this one. It's a reflection of this one in the x-axis, or it's a reflection of this one in the y-axis. It's going to look like that. So when we're sketching these curves, that's the first thing we need to consider, is which one of these 4 is it going to be in terms of its shape. So the one that I've got as an example to do with you first up is y equals 2e to the power of 3x plus 1. And if you remember what we looked at in the previous part of this lesson, we looked at transformations. You could consider that, okay, if we start with e to the x, we're going to get it squashing in by scale factor of 1/3. We're going to get it stretching in the y direction by scale factor 2. And we're going to get a y translation of plus 1. And that is one approach that you can take. But I often find that students think that's quite confusing. So what I'm going to show you now is a different approach, which hopefully you'll find a bit more accessible. So the first thing that we're going to do is we're going to think about what the shape of it is. Now we have e, we have power 3x. The most important thing is that it's positive, and it's positive here, therefore it's going to look like this. So the shape of this graph is going to be the standard e to the x shape. We're expecting our curve ultimately to look something like that. The next thing we're going to do is we're going to look at the intercept. And to do the intercept here, to get the y-intercept, we're going to make x equal 0. Which is true for any graph. If you're trying to find the y-intercept, make x equal 0. So y equals 2e to the power of 3 lots of 0 plus 1. So 3 lots of 0 is 0. E to the power of 0, well e is a number, remember, any number to the power of 0 is 1. So what I'm really getting here is I'm getting 2 lots of 1 plus 1, which is 3. So I can see that the y-intercept for this curve is going to be 0, 3. And the last thing that I need to think about with this one is the equation of the asymptote. Now, the way that I like to think about this is, we remember from the previous part of this lesson that e to the x cannot equal 0. So we think, okay, well, what if the e bit did equal 0? Well, if the e to the power 3x bit did equal 0, we'd have 2 times 0 plus 1, so y would be 1. Except the e bit can't be 0, and therefore y can't be 1. So if you cover up the bit with the e, because the e bit can't be 0, what you're left with is the asymptote. So in this case, the asymptote is y equals 1. Which again should make sense thinking about transformations, because what we have here is we have the original e curve stretched by scale factor 2, which you remember didn't change the asymptote, but plus 1, that's going to move the original asymptote of 0 up by 1, and we're now at y equals 1. So all that remains for me to do is to sketch in the asymptote at y equals 1, the y-intercept at 0, 3, and the shape I know is going to look like this. So I'm going to have an exponential curve, bit of tactical change there, there we go. I'm going to have an exponential curve that looks something like that, and that would continue down here, approaching this asymptote. So there we go. Shape, intercept, asymptote, and you cannot fail to draw the graph correctly. And that isn't a challenge, that's a statement. Join me in part 3 where we'll do another example of one of these.